Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSC in Institute of Aeronautical Engineering, Hyderabad. In this video, I am going to discuss about the secant method. So, secant method is one of the numerical integration methods. So, here the word secant comes from the Latin secant, means that to cut. So, this one is going to be used to find the root of the equation. So, here the roots sometimes may also called as zeros of the equations are going to be the values. So in which the equation is going to be satisfied. And for example, f of x equal to 0. And the secant method is not that breaking method. So because it is not required to change the signs between the estimations. So here the word secant comes from the Latin word what we call as a seeker, which is going to be means to cut it. So it is going to be used as root finding method, and the roots, what I said previously, of the equations are going to be the value for which the equation is going to be satisfied. And the secant method is not a break-taking method because it does not require any kind of signs between the estimations and all. So starting with the initial values like x0 and x1, suppose if I'm going to construct a line through the points like x0, f of x0 and x1 to f of x1. So then how am I going to find it? So x is equal to x1 minus f of x1 into x1 minus x0 by. So that should be f of x1 minus f of x0. Okay, suppose if initially you are going to have points and then how are we going to construct a line here. So we can make use of these values of x and x2 and repeat the process using x1 and x2 instead of x0 and x1, and we can able to continue the process also by solving x3 and x4 as well. So until we are going to reach a sufficiently high level of precision. So the new value, how we're going to find this new value. So the new value is going to be replaces the oldest value of x that is going to be used in calculation. So like x3 is how we're going to find it out means, so x2 minus f of x2, that is x2 minus x1 by f of x2 minus x1. So similarly how the x4 should be is, so x4 is equal to x3 minus f of x3, that should be x3 minus x2 by f of x3 minus f of x2. So similarly I can able to find x5. So x5 should be x4 minus f of x4 into x4 minus x3 by f of x4 minus f of x3. So like this we can able to continue the process to find the values, and finally this should be the nth term equation. So xn is equal to xn minus 1 minus f of xn minus 1 into xn minus 1 minus xn minus 2 divided by f of xn minus 1 minus f of xn minus 2. So in first two iterations, the graphs look like this. So where the red is going to be indicate the f of x value. So by making use of these two slack lines, which is going to meet the x1 value, x2 value, and then x1 value. So how are we going to be apply this method to find the root of the equation? So for this, I'm going to take the equation as cos x minus x into e power x, that should be equal to, so f of x equal to 0 and f of x value is this one. So for this what I'm going to say, so take an initial approximation value as x0 equal to 0 and x1 is equal to 1. So where we can have a secant method like f of 0 equal to 1 and f of 1 that should be cos 1 minus e power 1. So this value is going to be given as minus 2.17. So these are the ancient values that is going to be required for any sequent method here. And here what I'm going to say, so in order to apply this, so initially we have to know this f of x value, that should be, so cos x minus x power t power x, that should be 0. So for that I have to need to find what should be x naught and x1. So previously I explained some of the equations like this. So here how can I write it? F of x1 minus f of x naught. So by substituting these values, I can able to get these values at x0 and x1. So for f of 0, it should be 1 automatically, and then f of 1. So I'm going to substitute 1 in the equation. That should be cos 1 minus, so 1 into e power 1. So that should be cos 1 minus e. So this value should be 2 minus 2.177. So like this we are going to substitute the values. So for finding this, so for this I'm going to create the table like this. So where the k is going to take the values from 1 to n, and xk plus 1 is the under column I'm taking here, and then f of x plus 1 is the under value of what I'm going to take here. So in this what I'm going to say, so by substituting the values from x k plus 1, so I'm going to get first value as 0.314, and f of 1 value what I'm getting is 0.1519871. Similarly, by substituting the k value as 2 here, so I'm getting 0.44, and f of 2 x2 what I'm getting is 0.203. So by substituting the value of 3, I'm getting this one, and f of x3 should be what I'm getting as minus 0.429. And similarly, if I'm going to take another value k equal to 4, so here I'm going to consider another value 0.51, where I'm going to get 0.25. So by substituting all this, so I'm going to get these values. So by seeing this, the root is the value is same here for x7 and x8. So finally, this should be the root value of the equation. By substituting k value as 7, so here I'm going to get 0.5177 value, that is 573637. So by substituting 8 also, I'm going to get the same value here, so 0.1773637, right? So finally, this should be the value of this equation. So when it comes to advantages of this one, so this method does not require the computation of first order derivative. So this is one of the advantage of this. And here there is no need to check for the sign, and sometimes it is good to start finding a root using the bisection method, and then once you can know you are close to root and can able to switch to the new secant method to achieve the faster convergence. Okay. So sometimes it is good to start the finding the root using root bisection. Then once you know your method to achieve the faster convergence. So when the method convergence, it can be shown to have an order convergence. So which is nothing but 1.618. So this should be the good golden ratio. And this secant method is going to be convergence more rapidly near. So the first advantage is that so it does not require the computation of first order derivative, and need not to check the further sign is another thing. And it should be sometimes it is good to start to find the root using the bisection method once you can be able to know whether the closer the root or not. And when method the converges it is going to show the order of convergence. So the final value should be 1.618, and this method is going to be converged more rapidly nearer to the root. And when it comes to the disadvantage of this, so here this method is not a breaking method, so that it may not lead to the non-convergence. So another problem of this method is that it does not know when to stop. Okay, and it must be performed several times until the current gas is very small here, and if the function is very flat, and the secant method can also be failed. Okay, so the drawback of this method is that, so because the secant method is not a predicting method, it may not converge, and the problem of this method is that it does not know when to stop, and it must be performed several times until the current gas is very small. And if the function is very flat, then the secant method can fail. So if I'm going to have the equation like this, f of x is equal to 1 by x plus 1, x will minus 2. So by substituting the value, what I'm going to get some of the values like, so this should be the oldest value, and this after this is the after iteration, and this is the new value and the previous new value. So by seeing this graph, you can able to decide this should be the root value of this equation. So for that, what I'm going to say, I'm going to calculate x naught, x1 values, and f of x naught, f of x1, and then x2 and all. So by substituting this x0, so what I'm getting is, so x naught equal to 0 and 4, and then f of x naught is 0.5, and f of x naught is 0.6, and x2 is this, and f of x2 is this one. So similarly for x naught the value is 4, and x1 it should be 2.0, and f of x1 and f of x1 values I'm getting this one also. So what is the difference between this regular falsy and then secant method is that, so when compared this secant method with regular falsy, so it should be quite similar to the regular falsy, and then the condition is that, so the product of f of x1 and f of x2 should be less than 0, and here we can always the convergence and then speed should also be low here, and no need to check for the sign when compared to regular falsy, and we can able to algebra base with NP values, and the regular falsy should be a variant of this secant method, so which maintains a bracket around the solution, and the secant method should keep the most recent value estimates, while the false position retain the most recent estimations and the next recent one, so which has an opposite sign in the functional value. Okay, so the regular falsy also can mean, so it is similar to the regular falsy, and condition is that, so f of x1 and f of x2 should be less than 0. So the regular falsy will always show the convergence and speed should be low, so then there is no need to check for the sign here, and can always begin with a and b as usual. So the regular falsy should be a variant of the secant method, which should also maintain bracket around the solution. And secant method is the most recent, keeps the most recent two estimations, where the false position method retains most recent estimations. So by seeing, by making the comparison between the secant and false position, so by the form of a graph, so this should be the graph of the false position, and this should be the graph of the secant method. And when compared with this one and this one, this should be the quite different is there. So by looking at this graph. And next one, so what is the difference between this secant and Newton-Raphson method? So there should be a slight variation of Newton-Raphson method of functions, so whose derivatives are going to be difficult to evaluate. And the secant method has some properties as the Newton method, and the convergence is not guaranteed for all. And similarly to Newton-Raphson method, so except that derivative is going to be replaced with the finite difference. Okay, so the slight variation of this Newton method for the function is that, so here the derivations are going to be more difficult to evaluate. And the secant method has some properties as a Newton-Raphson method, and where the convergence is not guaranteed for all, it's not here. And it should also be similar to Newton Raphson, except the derivative is going to replace the final difference. And secant method is one of this analytical procedure to determine the earthquake engineers for predicting the earthquake performance of the structure, and can also going to use in designing the multi-story building. So this secant method is going to be used in many number of applications. So some of the applications will be to predict the performance of the earthquake, how much severe it is, and next one are going to be designed in multi-story building. So in those cases, in those applications, this secant method is going to be used. So when it comes to the geometric deviation, so the graph looks like this. So by taking the values of x and f of x along the y-axis, so by substituting the values of x less than x plus 1, so the graph looks like this. So by the concept of similar triangles in the triangle ABE and then CDE, so this one also going to be written as f of x, that should be divided by f of xi minus xi plus 1. Similarly, xi minus 1 is going to be divided by xi minus 1 into xi plus 1. So the secant method is going to be defined as, so xi plus 1 is equal to, so xi minus f of xi into xi minus 1, and that should be divided by f of xi minus xi minus 1. So this should be the equation we have to remember to implement this secant method. And finally the convergence. So here the convergence means, so the secant method is not a predicting method which may or may not converge. So but when the method converges, it is able to show the order of convergence should be equal to 1.6. Okay. So according to the convergence, the secant method is not a predicting method which may or may not converge. So whereas when method converges, it is going to show the order conversion function is 0.16. So that should be about the secant method. So in this video, I discussed the secant method. So the word secant comes from the Latin word that should be secant, should be able to cut it, and this should be going to be used as the root finding method, where the equation should be looks like f of x is equal to 0, and this secant method is not a predicting method because it is not required to change the sign between estimations. And if I'm going to consider this, the equation is going to be given like this. So x is equal to x minus f of x1 into x minus x naught of x1 into x naught. And by substituting these values, similarly you can able to find x3 and x4 as well. And these values are going to be noted in terms of xn should be written like this. And the first two iterations, how the graphs look like in the secant method is I'm showing here. And suppose if I'm going to consider an example by taking the function as f of x, what is it? That means where f of x should be cos x minus x into e of x. So by substituting the values in x0 and x1, I'm going to get some two values initially. So this should be the initial step, what I'm going to do in this secant method. So by substituting these values, I can able to find where the key value is going to be moved from 1 to n. So while moving, can able to observe this. The sum of the values are going to be same in the case of x, where the key value is 7 and 8. So that should be the final step. So that means that should be the root value of the given equation. So when it comes to the advantages of this, so normally it does not require any computation of first order derivative and no need to check for its sign. So this is the another advantage. And sometimes it is good to find the starting the root using bisection method. So once you are close to the root, then you can able to switch the a new method to the faster convergence. So finally, this convergence value should be like 1.618, and the secant method converges more rapidly as well. So when it comes to drawback of the secant method, so the secant method is not a batching method because it may not converge. So the under problem of this method is that it does not know when to stop. So it must be performed several times. So until the current base is very small. So if the function is very flat, so the secant method can fail. So this is another example what I consider, and then substituting the values, I'm going to get some of the values here. Then failure may occur. So this secant method is going to be compared with some other methods like regular falsy. So when compared this to regular falsy, so the condition should be above x1 and x2 should be less than 0. That should be initial condition, and we can always converge it, and then the speed can also be slow, and no need to check for the sign. So we can able to begin with the NB as usual. And the regular falsy should be a variant of secant, so we should be able to maintain the bracket around the solution. And the comparison between the secant and regular falsy is going to be shown in the form of graph, so how it is going to differ with the false precision method. And this secant is also going to be compared with neutral absent, so there should be a slight variation when compared to this neutral absent, so where the deviations are going to be difficult to avoid. And it should be something have the same properties is going to have, where the convergence is also not guaranteed for. And secant method should be one of the analytical procedures where mainly going to be used in predicting the actual performance, and then we can also be identify the design of the multi-story building by using this method. So when can able to see the concepts of similar triangles, here the concept should also be seen, and method and the equation what I'm going to get should be shown here. So convergence, so what I said previously, the convergence value should be lies between 1.6. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.